Yo, ladies and gentlemen, welcome back to a new video. Today we're going to be talking about the wireless power transmission. Yeah, I know I have actually made the wireless power transmission a while back, actually using a one-off transistor oscillating circuit about 2 years ago, and yeah, I know now you get it. Now in this video we are not just going to be making a wireless power transmission, we are also going to be making a simple upgrade on this wireless power transmission. Yeah, the first time I actually used the one transistor to create the wireless power transmission using a self-oscillating transistor, but in this video we are also going to be using a 555 time IC chip to make the wireless power transmission and see which one is best. So stay tuned to the ending of this video, and if you haven't subscribed, hit the subscribe button. Let's dive in. Now I know the first question which is going to be coming to your mind is, what is wireless power transmission? Yeah, I know in a while back I actually made the video actually using a one transistor to create the wireless power transmission. I actually explained how it works, but never mind, I'm really going to explain again how it works in more details. Now a wireless power transmission actually works on the electromagnetic effect. Yeah, this is actually a theory which you need to learn, but never mind, I'm just going to explain it. Now the wireless power transmission actually works on the theory of electromagnetic induction. Yeah, electromagnetic induction, whereby the transceiver coil transmits electromagnetic from it to the receiving coil. Thereby the receiving coil receives that electromagnetic field, turning on the LED which is actually connected to it. Now you get it? Now let's go to another fact. Now in the last circuit I actually used a one transistor to create the wireless power transmission. Yes, that is a self-oscillating one transistor project. I know it's really good to learn from that circuit, but also in this video we are also going to be using the 555 timer IC chip, as I said earlier, to create our own frequency to go into the transceiver coil directly, instead of using a one transistor to create a frequency, and which is kind of inefficient. But nevertheless, firstly in this video we are also going to be recreating the one self-oscillating transistor type of wireless power transmission to kind of understand it first before we go to the 555 timer based wireless power transmission. Right here on my desk I have the S8050 transistor. Yeah, this is actually a type of transistor which is not actually a power transistor, and it's definitely going to get hot, and it's just a high frequency transistor. That's why I choose it, and it's definitely going to get hot. So we are going to be using 1.5 volt on this circuit, and let's test it out. Making the connections are very simple and very easy. The base of the transistor is actually going to one side of the coil. The center tab of the coil is actually going to positive. The other side of the coil, which is the other ending of the coil, is actually going to the collector side of the transistor, while the emitter side of the transistor is then going to ground. We're powering it up with 1.5 volts. Here's our result. But wait a second, I didn't actually tell you how to make the coil winding. Now, in making the transmitting coil winding, we are expected to have a center tab. Yeah, I made a couple of turns, about total of 15 turns on the transmitter and the receiving coil. Yeah, but I got a center tab from the transmitting coil. This is how to do it. I winded 7.5 turns, then I drag out the center tab, then continue the remaining 7.5, which amount to 15 turns. But in the receiving coil I didn't created any center tab because it wasn't needed. I know also you're going to be asking me, what is the use of the center tab in this circuit? Yeah, this is actually a self-oscillating circuit, so the center tab is actually needed to create a continuous loop. Yeah, it's without the center tab the project or the circuit will not continue to oscillate. I'm going to explain this in the ending of the video, so you do well to stay tuned, and also do well to subscribe to my channel, because we are planning on reaching 500 subscribers before the ending of next month, and 1,000 subscribers before the ending of this year. Please join my goal and help a small content creator like me, which is trying to become something in the future. For the receiving coil, we are just going to be using this 1.5 volt blue LED, connecting it to each of the terminals. Note, when you are testing your project and you found out that your circuit is not working, you can just flip the coil, or you can just change the connections of the leg pins to the coil, to the receiving coil, and see if that fixes out. Now let's test the circuit. Three, 2, 1, boom. Yep, you can see it actually works, but actually not really bright, but our transistor is definitely getting really hot, so we have to disconnect in a while. You can see the circuit works. Now let me explain how this circuit actually works. Normally in the beginning, I actually said all of this circuit actually work on electromagnetic induction, but this particular circuit which I actually made have its own theory of working, have its own working theory process. Now in explaining it much better, bringing out the transmitting coil, we can see that we have a center tab and we have a starting wire and an ending wire right there. Now we can call one side a feedback coil and the other side a primary coil. A feedback coil is actually what continues the loop and creates the oscillating journey. Now the first pin of the transceiving coil, I don't know if you can understand it, the first starting leg is connected to the base of the transistor, and then the center tab side of the transceiving coil is actually connected to positive. This side is actually connected to the base of the transistor. Is actually, you can use a resistor to create to save the base from over voltage or something like that. And also this circuit actually also need a flyback diode, which I actually didn't put, but you can put it to protect the transistor from the coil reverse voltage, but I'm going to be explaining that later on. Now let's jump right into how it works. Now, as I said earlier, one leg of the transceiving coil is actually connected to the base of the transistor through a resistor. You can use a 1K or 2.2K, any amount you want to use according to what the voltage you are using. Then the center tab is actually connected to the positive side of the battery. Now we can call that a feedback coil. Now when you apply voltage to your circuit, voltage flows to the center tab to the base of the transistor, turning the transistor on. This allows current to flow from the emitter to the collector, thereby completing the circuit and turning on the primary coil. Like, in other words, giving power to the primary coil. Giving power to the other coil. In the beginning I actually said you have two coils, you have 3 pins. You have 3 pins: the first leg, the center tab, and the last leg. Now the first leg is actually connected to the base through a resistor. The center tab is actually connected to the positive side of the battery, and the last leg of the transceiving coil is actually connected to the collector of the transistor. So when these feedback coil, we're going to be calling it feedback coil, when this feedback coil receives positive voltage, when the circuit is powered, it actually flows through the feedback coil going to the base. There is no electromagnetic induction yet. It just flows through that coil, connecting the base, closing the circuit, thereby allowing current to flow from the emitter to the collector, thereby completing the circuit and turning on the primary coil. Now this primary coil now starts the electromagnetic induction. Now this primary coil, once it's turned on, an electromagnetic field is induced into the feedback coil, thereby allowing a much larger voltage to go to the base of the transistor. You hear me very well. So the feedback coil is very important. Without the feedback coil, the oscillating process does not continue. So as I said, when the primary coil is now completed and powered on, it creates an electromagnetic field induction induced into the feedback coil. That feedback coil feeds it into the base of the transistor again, thereby powering the transistor more, thereby allowing more current to flow. if you understand on the electromagnetic induction, you can see that when the primary coil induces a voltage on the feedback coil, when it induces a field into the feedback coil, the voltage increases and it sends more current to the base of the transistor, thereby turning the transistor completely on. Now, after a while, this magnetic field actually collapses, thereby creating a negative pulse. This negative pulse flows to the base of the transistor, thereby shutting down the transistor. This transistor turns off. When the transistor turns off, the cycle repeats again. It's really simple to understand. I know there are other kind of slight explanations that are also similar to my own, but I also know that there's some corrections and maybe some adjustment. Let me know in the comment section below, and I'll accept you and still see if I can understand what you're talking about and see on your explanations. Let me know if you have any other explanations in your brains. I know there are actually two explanations for this, but this is one of the aspects. I'll actually save the second explanation to my patrons, and so if you want to join my Patreon, check in the link in the description or just go to Patreon at Successful Electronics. I have two explanations for this. I shared one with you and the other one is actually similar, but I'm actually really getting confused, so I'm going to share it with my Patreon and see if I can get a clue. Once I'm cleared with the explanations, I can come and share it with you guys. So this is actually how this one self-oscillating transistor actually works. Let's quickly go to the 5 time. But wait a second, I think the video is getting too long. I'm so sorry guys. I'm really gonna make a part 2 for this video. So in the part 2, I'm gonna be talking about the 4-5 timer connection process, but we are gonna be ending right now on the explanation. Stay tuned to the next episode, which is gonna be part 2, which I'm gonna be talking about the connection aspect of using the 555 timer IC chip to create the wireless power transmission. Thank you very much for watching, and I'll see you in part 2.